In this video, we will look at how the Huron system can be used to build a large database including a corpus of texts with all their phonological and rhythmic details. While you can always analyze a single verse or sentence and get immediate results, in most cases the system will analyze entire documents, storing its data in a relational database. In this database, there are four main areas. The first area includes all the data about input documents, including their text. This way, the resulting database is a self-contained corpus, including both text with its metadata and all the analysis details performed on top of it. The second area includes all the details about the analysis performed on top of a text, wrapped into sessions. Each analysis session has its own parameters, so that the database can include an unlimited number of analysis data for the same text. The third area contains observations of phenomena, as defined by scholars and implemented by specific modules. This defines a clear boundary between data collected from analysis and observations made on top of them, as observations imply various degrees of interpretation. Finally, Prose Rhythm adds some more specialized data, which can be the source of further observations. As for the documents area, essentially it contains the documents themselves, with their metadata like author, title, date, literary genre, etc. There is no limit to such metadata. Further, we can group documents into corpora, so that we can handle many operations on them as a whole. The analysis area contains most of the data. Each analysis performed for storage belongs to a session. A session has its metadata and profile, which defines the configuration of the analysis pipeline. This way you can perform analysis with different parameters on the same texts. Documents are analyzed into text units, which correspond to a single unit of analysis. This corresponds to the verse for poetry, or to the sentence for prose. Each unit is then fully analyzed by one or more modules in the pipeline, ranging from prosodies to syntax and metrics, or more specialized layers. All the resulting data are stored into analyzed units. Once we have systematically collected all the data about our text, we can reflect on it by observing any phenomenon of interest. Phenomena can be either well-known features or just work hypotheses. They cover all the layers of analysis, from phonology to prosodies, syntax, metrics, or other specialized layers. Each phenomenon is observed by a modular component, named observer. Observers produce observations, which are stored in the database. Their model is a set of features, especially designed for use with data science tools. Finally, an additional area in the database is reserved to Prose Rhythm. Prose Rhythm relies on the basic analysis and is performed on the whole sentence rather than just at its end. This implies that many different patterns can be potentially detected in each context. All the patterns possible within rhythmic and linguistic constraints are explored, evaluated, and stored. Then, observations of Prose Rhythm can be made on top of these supplementary data. Let's have a quick look at documents. This list shows all the documents of a Greek epic corpus, ranging from Homer to the 6th century AD. As you can see, each document represents a specific partition inside a work. For instance, Apollonius Argonautica are divided into 4 documents, each representing a book. The most relevant metadata are shown in the list. By editing a document, you can change its metadata and also specify the default analysis profile and its content. Depending on the document's size, you can either paste it or upload it from a file. As you can see, the content is mostly plain text. Some non-intrusive annotations have been inserted here by the analysis process itself, or might come from third-party tools, like for instance NLP taggers. Whatever their origin, they are isolated in their own line, so that the original plain text is not touched. If we now look back to the list, we can get more details about each document, including its analysis. Let us pick the first book of Argonautica. As you can see, all the document's metadata are listed here. Further, the database is queried to get the details about its analysis. In this diagram, each square represents a single analysis unit. In the case of this poetical work, this corresponds to a single verse. At the bottom of the diagram, you can see the count of verses, here 1362. Red squares represent those verses where a full analysis could not be completed, essentially because the text is corrupted. At any rate, all the possible analysis stages were performed anyway. As you can see, there are just a couple of such verses in this book. When hovering on squares, we also get the unit number and the count of observations attached to it. This provides a glimpse about the amount of phenomena observed in it. So, this is a bird's-eye view on documents units. Anyway, we can always move from distant to close reading. Here, for instance, we can move from a full book of a work and plunge into the details of each single verse, up to the subphonematic level. Let's just click on any of the squares, like the first one, which is the first verse of this work. As you can see, we get the verse with its full analysis details. You can learn more about this view in another video. In short, you can see the phonological approximated values in the blue row, the corresponding opening levels in the bars, the syllabic weights in the green row, and the metrical units in the red one. The figures at the right edge show that this verse contains 17 syllables, 42 segments, and 393 traits. Traits are name and value pairs, representing any type of data about segments, including their phonological traits proper, and much more, from all the analysis layers, up to metrics. We can inspect the details of each single segment and all its traits by just clicking on it. As you can see, there are a lot of them, for each single segment of each verse in this document. This provides the full details of the analysis performed by the system in an interactive view. So, once you have performed one or more analyses on your corpus, you end up with a database including all the texts and all the data about them. This produces a sort of interactive, highly structured rhythmic representation of the texts in a standard database which can be queried by either this system or any other third-party software. Given the level of details, we are thus able to generate real big data about a highly approximated phonological and rhythmic representation of our texts. For instance, let us consider our sample Greek epic corpus, ranging from the 8th century before Christ to the 6th century of our era. Here we have a total of 206 documents, from Homer to Nanos. These are analyzed into 86,225 units, each representing a verse. In prose, units would rather be sentences. By observing 19 specific phenomena on the base data, we gain 6,551,400 observations. Such observations may cover any level of analysis, at any level of detail, and are modeled as multidimensional feature sets. Observations rely on the core data collected by phonological, syntactic, and metrical analysis on each verse, up to subphonematic details. For instance, in these verses we count 571,871 tokens. The total count of syllables in these tokens is 1,373,445. Even going deeper, we can count 3,105,463 segments building up these syllables. Segments are roughly equivalent to phonemes. And finally, reaching the subphonematic level, we gain the huge number of more than 35 million traits. As you have seen, traits represent any type of metadata attached to a segment, including what are known as traits proper in linguistics. So, we started with a bunch of plain text files, in their written form, and we ended with big data about their spoken form, with all the additional details about the rhythmic patterns they build in poetry as well as in prose. Of course, even if we can totally change the analysis parameters to best fit different eras or genres, these are really schematic approximations, which only provide a pale and rough picture of the hypothetical sounds. Nonetheless, their huge quantity provides some balance to these approximations, and paves the way to a wealth of computational approaches, just like the availability of huge corpora of written texts has boosted many fields of research via NLP techniques for tagging them. In a sense, this is going to provide a crutch for a two-legged approach, where language analysis can rely not only on the graphical plane, but also on some approximated representation of the phonetic one. While on the graphical plane a lot of invaluable tools are available for tasks like part-of-speech tagging, tree tagging, or even semantic analysis, on the phonetic plane a wide base of corpora is still missing. A system like this can thus be used to provide a foundation for this complementary plane, as approximately defined by writing, ancient sources, historical and comparative linguistics. This is especially useful when dealing with corpora like the one sampled here, which has its roots in orality, and has been deeply based on a spoken rather than written publication. In fact, up to Hellenistic age, poetry targets an audience of listeners, rather than of readers. Further, poetry formally is the regulation of selected phonological features of a language, building patterns based on repetition. This implies that a computational approach to its evaluation can't be done without resting on the ground of a systematic collection of phonological data, before any attempt to interpret them. This is why the system focuses on the distinction between data collection, as represented by all the analysis levels applied through its pipeline, and its interpretation, as represented by observations and further data processing using data science techniques, ending up with millions of fresh data. This treasure trove of information can allow us to transcend temporal, cultural, and linguistic boundaries. We can scrutinize relationships between different genres, systems, such as Greek or Latin versification, and even traverse time itself. Imagine late antique or medieval scholars, their ears attuned to the nuances of the sound of a new language, reshaping their venerable quantitative models, thus birthing new versification types across the great transition zones of literary and linguistic evolution. In this symphony of data, the phonetic notes harmonize with the graphical chords, creating a richer, more resonant understanding of language and its artistic usage, a symphony that echoes across epochs and cultures. You can find more about Huron at this page. Thank you for watching.